Hey everyone, and welcome back. If you're like me and fascinated by the world of AI and coding, you're going to love this. Today we're doing a deep dive into something truly groundbreaking. Qwen2.5-Coder.
It's not your typical code generation tool.
Not at all. We're talking about a series of powerful open source models designed to be absolute coding powerhouses.
They can generate code, complete code, reason about code, even repair code.
And get this, they can handle incredibly long stretches of code, up to 128,000 tokens long.
That's like processing a whole library worth of code.
It's mind-boggling. We've got the technical report that dives deep into how these models were built and how they perform. So let's unpack it together.
Sounds good.
First things first, what exactly is Qwen2.5-Coder?
Well, it's actually a series of 6 different models.
Oh, interesting. So it's not just one single model.
Right. Each one is built with a different number of parameters, making them progressively more powerful.
So bigger model, more power.
You got it. The smallest has 500 million parameters, and the largest one has a whopping 32 billion.
Wow, 32 billion. That's immense. I remember reading that this largest model is actually on par with some of the leading closed source models out there, even GPT-4o.
It is. It's pretty remarkable, especially considering it's open source, meaning anyone can access and use it.
That is a huge advantage for researchers and developers. Okay, so we've got 6 models, each with varying levels of power. What else makes Qwen2.5-Coder unique?
Well, it starts with its foundation. It's built upon Qwen2.5, a more general-purpose language model.
So they took a generalist and honed it into a specialist, a coding expert.
Exactly. They fine-tuned and optimized it for everything code-related.
I see. So how do these models actually work? The report mentions something called Qwen2.5-Coder data. What's that all about?
That's where the magic begins. It's a massive data set used to train these models over 5.5 trillion tokens. We're talking source code in various programming languages, text, math problems, even data synthesized by other AI models.
Wow, a real mix of everything. Why so much and why such a variety?
They discovered that a specific blend worked best. 70% code, 20% text, and 10% math data.
Interesting. A balanced diet for a well-rounded model.
Exactly. They found that this mix helped the models develop a really deep understanding of code and its real-world applications.
So quantity and quality matter. Now, the report also mentions a 3-stage training process. Sounds pretty complex.
It is, but each stage plays a crucial role in unlocking the model's potential. The first stage is file-level pre-training.
Okay, break that down for me. What happens in this stage?
The model learns from individual code files. They use techniques like next token prediction, where the model has to predict the next word in a sequence of code, almost like a coding puzzle.
So it's learning to anticipate what comes next, like a programmer would.
Right. They also use fill in the middle, or FEM, where the model has to fill in missing chunks of code based on the surrounding context.
Like it's given a code snippet with gaps and has to figure out what belongs there?
Exactly. It's a great way for the model to understand code structure and dependencies.
Okay, so it's learning the basics. But then it goes to a whole other level with repo-level pre-training, right?
That's right. We move from individual files to entire code repositories.
Wow, that's a huge jump in scale.
It is. We're talking about thousands of files and millions of lines of code. They even managed to push the boundaries here, allowing the model to handle incredibly long sequences, up to 128,000 tokens.
Wait, remind me, what are tokens again?
Think of tokens as the fundamental building blocks of language, both natural language and programming languages. Words, punctuation marks, even special characters used in code, it's all broken down into these tokens.
So at the repo level, the model is learning to understand how these tokens connect in a much larger context, like an entire software project.
Exactly. It's like going from reading single sentences to understanding complete novels.
Pretty impressive. And then there's this third stage, instruction tuning, right?
Yes, that's where things get particularly interesting.
I'm hooked. What happens in this stage?
This is where we go from simply understanding code to using it. The model learns to follow instructions, answer questions about code, and even generate code to solve tasks.
So it becomes a coding assistant, almost like having a superpowered programmer at your fingertips.
Right. They train the model using a massive data set of instructions paired with correct code solutions.
Wait, how do you even create a data set like that for code? And how do you make sure the solutions are accurate?
That's where things get really clever. They used other AI models like CodeBERT to identify the programming language from text. And then they used LLMs, large language models, to generate instructions from existing code snippets. To ensure accuracy, they actually built a multilingual code sandbox to run and test the generated code.
So they're using AI to train AI. It's like a whole ecosystem of models working together.
Exactly. They even used a multi-agent system where different agents specialize in different programming languages to generate multilingual instruction data.
Wow, they really thought of everything. But with all this training, how do we know if it actually works? How do they test if Qwen 2.5 Coder actually lives up to the hype?
That's where the evaluation phase comes in. And trust me, they didn't go easy on Qwen 2.5 Coder.
So spill the beans. What kind of test did they put it through?
They used a battery of industry-standard benchmarks to really see how well it performs across various coding tasks.
Okay, I'm on the edge of my seat. How did it do?
Let's just say the results were pretty impressive. Qwen 2.5 Coder consistently outperformed other open source models.
Okay, that's good. But what about those big closed source models everyone talks about? How does it compare to those?
Well, in many cases, it actually surpassed them too.
No way. That's a bold statement. Give me some highlights. What were some of the standout results?
One area where Qwen 2.5 Coder really shined was code completion, especially when it came to cross-file contexts.
Cross-file context. What does that even mean?
Imagine you're working on a big software project, maybe with hundreds or even thousands of files.
Oh, I see what you mean. Lots of moving parts.
Exactly. To complete code accurately, the model needs to understand not just the current file you're working on, but also how it relates to all the other files in the project.
So it's like understanding the big picture, how everything fits together.
Precisely. And Qwen 2.5 Coder aced these tests. They used benchmarks like cross-code-evil and repu-evil designed to specifically assess this ability. The results were remarkable.
You mentioned it even outperformed some of the larger closed source models. Can you give me an example?
Sure. One that really stands out is the 7 billion parameter version of Qwen 2.5 Coder. It actually beat a 33 billion parameter model called dscoder on a number of metrics.
Wait, a smaller model beat a much larger one? That's wild. How's that even possible?
It really highlights the strength of their training approach. Remember that fill in the middle, the FEM technique we talked about earlier?
Yeah, where the model has to predict the missing pieces of code?
It turns out that technique is particularly effective for helping the model grasp code structure and dependencies at a deep level. By training on tons of code using FEM, Qwen 2.5 Coder became really good at filling in the blanks, even in really complex code bases.
So it's not just about size. It's about how you train it and what you train it on. It's about quality over quantity.
Absolutely. And this wasn't just a one-off thing. This pattern was consistent across other benchmarks, too. They tested how well Qwen 2.5 Coder could generate entire functions from scratch, how it completed code within entire repositories, even how it dealt with incredibly long sequences of code.
And it did well across the board.
It did. It performed exceptionally well.
Okay, I'm definitely starting to see why they call this a coding powerhouse. But all this talk about benchmarks and metrics, it can get a bit abstract. What does this actually mean for real-world coding? How can developers use these models?
That's the question everyone's asking, and it's exciting to think about. One obvious application is in code completion tools.
Oh, you mean like the suggestions you get in your IDE as you're typing?
Right, but imagine that on a whole new level. An IDE that can predict not just the next word, but whole lines of code, taking into account the entire context of your project.
That would be amazing. No more struggling with boilerplate code or trying to remember all those syntax details?
Exactly. It goes beyond just completion, though. These models could help with code generation, helping developers build prototypes or the basic structure for new features much faster.
And I bet they could be super useful for debugging. Imagine having a model that could not only spot errors, but suggest fixes based on its knowledge of code.
And don't forget documentation. These models could automatically generate documentation from the code, keeping everything up to date, saving so much time and effort.
So it's not just about speed, it's about efficiency and productivity. And ultimately, it could make developers more creative, right?
Precisely. If developers can spend less time on those tedious tasks, they're free to focus on the truly innovative parts of software development.
This all sounds so promising. But are there any challenges? What are some of the hurdles researchers still need to address in this field?
One of the biggest ones is bias. Just like any AI model, code language models learn from the data they're trained on, and that data can reflect the biases of the people who created it.
So if the training data is skewed towards a particular style or a certain group of programmers, the model might unintentionally learn to code in a way that perpetuates those biases.
That's right. And this is a serious issue, especially if these models are used in sensitive fields like healthcare or finance, We have to make sure the training data is as diverse and representative as possible.
Makes sense. Another thing that comes to mind is explainability. These models are incredibly complex. It can be hard to understand why they make the decisions they do.
That's a valid concern, especially as they get more powerful and are used in more critical applications. We need to understand how they work and why they make certain choices.
Otherwise, we're basically trusting a black box to write our code. We might get the result we want, but we have no idea how it got there or what might go wrong.
Exactly. Explainability is key for trust, transparency, and debugging. Luckily, there's a lot of research happening in this area, developing ways to visualize the model's decision-making process and understand how it works.
That's good to hear. So bias and explainability are two big challenges. What else is on the horizon for this field? What's next?
Well, the research team behind Qwen2.5-Coder isn't stopping here. They're already talking about building even bigger, more capable models, really pushing the boundaries of what AI can do.
This is an example of structured data understanding
capable of
generating
so
business.
rapidly, I'm sure we'll see even more breakthroughs in the near future.
Absolutely. The future of AI-powered coding is looking very bright.
But before we get too carried away with the future, there's one more important aspect of Qwen2.5-Coder we haven't talked about yet. Its open source nature.
Right. That's a big deal.
So let's dig into that in the next part of our deep dive. We'll talk about what it means for a code language model to be open source, the pros and cons, and what it could mean for the future of AI in coding. Okay, let's talk open source. Why is everyone making such a big deal about Qwen2.5-Coder being open source? What does that even mean for a code language model?
It's a big deal because it really changes things. Up until now, most of the really powerful AI models have been developed by big tech companies, and they keep them pretty secret.
Like their own secret weapon in the AI world.
Yeah, exactly. It gives them an advantage, so they don't want to share. But open source totally flips that idea on its head.
So it's like they're sharing their secret recipe with the whole world. What does that mean for everyone else?
Well, for starters, it means anyone can look at the model's code. Researchers can study it, figure out how it works, and maybe even find ways to make it better.
So transparency is key. It builds trust and allows everyone to work together.
Right. It means people can check if the model really does what it claims to do, and they can also customize it.
Customize it, like tweak it to do specific things.
Exactly. They could adapt it to work with new programming languages, make it better at certain tasks, or even integrate it into their own tools.
That's pretty cool.
Yeah.
And it's not just for researchers and developers, right? What about businesses or individuals who want to use AI for coding?
That's another huge benefit of open source. It levels the playing field, making these powerful tools available to anyone. No need to pay huge fees or rely on big tech companies.
So open source helps create a more democratic and inclusive AI world.
Yes, exactly. More people can experiment, come up with new ideas, and work together. Who knows what amazing applications we'll see?
It all sounds pretty amazing, but I'm guessing there are some downsides to open source too, right?
Of course. One big one is maintenance. Who's going to make sure the code stays updated, fix any bugs, and keep it secure?
That's a big responsibility, especially with a model as complex as Qwen2.5-Coder.
It definitely needs a dedicated team with the right skills and resources. Thankfully, the team at Alibaba who created Qwen2.5-Coder have said they will maintain it, and they're encouraging others to contribute too.
So it's a community effort. That's good to know. But what about misuse? Is there anything to stop someone from using Qwen2.5-Coder to create harmful code?
That's a valid concern with any technology this powerful. We need to be careful and put safeguards in place.
Like what kind of safeguards?
It's a mix of technical stuff and ethical guidelines. We need ways to detect and filter out dangerous code. And we also need to agree on some ethical rules for using AI in coding.
So it's everyone's responsibility to make sure these tools are used for good.
Absolutely. Researchers, developers, policymakers, everyone needs to work together.
Open sourcing Qwen2.5-Coder seems like a big step, a bit of a risk, but potentially really transformative.
It is uncharted territory, but I think it's a risk worth taking. Making these models more open and accessible could lead to incredible things.
It's empowering a whole community of people to innovate and explore new possibilities with AI and coding.
Who knows what groundbreaking discoveries are waiting to be made?
Well, that wraps up our deep dive into Qwen2.5-Coder. We've covered a lot, from its impressive abilities and how it was trained to the implications of it being open source.
We've seen how AI has the potential to completely change how we write code and interact with it.
And we've had a glimpse of the exciting and sometimes challenging future of AI in coding.
It's an exciting time to be in this field. Qwen2.5-Coder is a great example of what's possible.
Thanks for joining us. We'll be back with more deep dives into the cutting-edge world of AI.
Until then, keep exploring.